Hello guys, welcome back. In this video, let us see and observe and analyze what is the semantic search and how to do this in practical. And or you can also observe how to search or how to search a top 5 articles based on the query that you provided. So in order to tell you this with an example, first I want a document, and second I want to provide a query about the document. So in order to use a document, I'm just moving on with the open source document that is multi-news that is available in Hugging Face. So how can I able to load the data set? So in order to load that particular data set, so which is present in multi-news, I want to first import this load data set. So from where I can able to import this load data set? I can able to import this from data sets. This load data set is present. So if you haven't installed it, then please install this data sets first before using that data set. Now I want to, and in this data set also I have a lot of amount of data. This is Agniface open source data set. So in this I just want test data. So I'm using this split command to get only the test data, and so I'm just loading this into a data set variable. And yeah, so I have loaded my data set into this variable. Now I want to create a data frame from this data set. So how can I able to create the data frame from any data set is data set dot to, you can see two pandas option is also there. So I'm using that to create a data frame. And so in the data frame, I don't want all the data. I just want only top, or you can say random 2000 samples. So that's why I'm providing a 2000 here. And so the random state I want to say. So random state, I want to say it as a 42. Yes, it's a random state. You need to pick only 2000 samples from this data set. Now I got the data frame as well. So now what I want, I just want a model. So in order to load this data set, or you can say in order to encode this data set, I need a model. Now I've just entered so that you can see that all the required libraries are already installed. So those all will be visible right now here. Now I want to show you what model that I want to use in order to use or in order to load or encode this data set. So since I'm loading the whole sentences, first I want to show you the data frame what I'm getting, so that you'll get an idea of this semantic search.py. Yeah, so you'll get an idea. So I'm just loading a data set which contains a document as well as a summary. In the document session, I have whole the document available, as well as in the summary session. So I got some error. So what's that? Multi-news does not exist. So here it's not multi-news. MUTLI. So it's not MUTLI, it's MULTI. So if you did any spelling mistakes like this, then you might get the same type of error. So you need to once check with the code that I have written here, so that you can able to rectify your errors. So I'm rerunning it to see my data frame. You can see here, I have mainly, you can see this is the index column. So forget it. This is the document column and this is the summary column. In this document column, I have a whole document, and this is the summary of that whole document. Now this is the data frame I have. So what I'm expecting is I want to query my summary or a document. So based on what question I want. Based on the question that I have provided, I need to get the similar similar documents as a suggestion. So like that I want to do in this. So in order to perform that similarity search, so I'm just going to Google, and again here I'm searching for sentence related transformers, since I have sentences in my document as well as in my query. So based on that I'm doing search, so that's why I'm opening this. You can see sentence transformers are already there. I'm just opening this documentation. In this you can see this is the all mini language model L6 version 2. I'm just using the same model in order to perform this sentence search. So if you take this as an example, then you can able to provide some question, and you can able to identify the similarity search inside it. So this is what we can implement, and apart of this I'll also provide you some more clarification. That is for my query, what are the documents that I'm getting. So that also I want to display. And here if you observe, pre-trained models are already there, multiple models are there. You can able to pick what are the needed for you. STS benchmark is there. So based on the use case that you have and the requirements that you have, you need to pick a best suitable model for you. For this demo I'm just picking the default model, that is this all mini LM L6 V2 model. So in order to use that model, first we need to import, or first we need to install the packages that we want. The package that we want to install, that is this, you can see. So sentence transformers, pip install upgraded version of this sentence transformers. I'm just clicking on enter, so that meanwhile this gets installed. Now I want to import that. So from sentence underscore transformers, I want to import this sentence transformer, and by using that sentence transformer I want to load a model with the model name. That model name is nothing but what are the model name that I have copied. So what is the by using the sentence transformer I want to load this model, so that's why I'm providing this model name, and I want to store that model inside this model variable. And first I want to encode this data frame whatever I have. And so in order to encode the data frame by using the model I have, just use the command, that is a model dot encode of what you want to encode. I want to encode this data frame, so that's why I provided this. And in this data frame also I just want to encode the summary data, so that it is encoding a less amount of data, and I'll get the appropriate and fast response. So data frame of this summary I'm providing. And so actually we not provide these data frames directly to our model to encode. We just need to provide a list format data. So that's why I'm converting this to list. You can see that option is there that I'm providing. And in this also I want to store this data, whatever the result I'm getting, in the form of a list in a variable, that is this data frame underscore. So since these are embeddings, I want to store like a variable name like embeddings. Yeah. So I just don't need to print these data frames again and again, and just need to print these data frame embeddings right now. Yeah. So now we successfully loaded our data set, and we imported the model that we want, and we encoded our data set successfully. And you can see within a few seconds you will get this embeddings that you just generated from your data frame. Now you can create some sample query like so suggest me some articles. Now you can see a lot of embeddings were generated for this data frame. So since that is a lot of data, so for this data frame or package or document, a lot of data is generated, and that's got printed here. So I'm just scrolling it up or down if it is getting a lot of data. Okay. Now I've provided a question that is suggest me some article related to artificial intelligence. Okay, like that I'm providing the question query. Now I want to convert this into, I want to encode this, or you can say I want to generate the embeddings of this query and store that in this query embeddings variable. So how can I able to generate the embeddings? Just simple model dot encode of this query. So now you will get the query embeddings as well. Now I want to identify the similarity between these two. So what are the question that I have provided as well as my data frame. So how can I able to provide the similarity between them? You can use the util. You can able to use the util inside this sentence transformer. So that util, it will provide you cosine similarity. So I'm just using that cosine similarity to identify the similarity between these two sentences. So what is the similarities? Util dot cos sim of, so what query you want to provide. So this query embeddings for this question, I want to identify the similarities in this data frame embeddings. So this document embeddings I have provided, and I want to store that result in so similarities variable, so that I'll get the similarities between the question and the provided data. In those all packages, I just want top 3 packages. I can able to get those top 3 by using a torch. So torch, so in order to filter only top k values from all these similarities dot flatten. I'm using this top k from torch, and I'm just getting the indices, and I'm just storing the top indices in this top indices variable. So now I'll get the top indices. So among the top indices as well, I just want to pick the summary, or I just want to pick the data and print that data. Just I want to pick the index. So I want to pick each and every index in top indices. And so in that index also, what I want, I just want to take the items. So index dot items I'm picking. And so what I want, I just want a summary, right? I just want summary. So that's why in my data frame, I want to use this data frame dot I LOC. So item location of this item. And then in this also, I'm just picking the summary and top 200 words I'm picking, and just printing that data here. And at last, I just put so on. Yeah, that's it. So simply let's run this so that we need to get the result for this query. That is suggest me some articles related to artificial intelligence. CIAL. I think we made a spell mistake here. Okay. So related to this question, so what are the embeddings that are present in this data frame embeddings? Among those, what we are picking a top K by using this torch, and we simply printing just 200 lines from each and every, just 200 characters from each and every summary. Yeah, that's it. And so on we are printing. So let's see the output to identify the articles are printed or not. So this is the code that we use till now. if we recap, then it's very simple. We just loaded the data set and converted it into pandas and pick only 2000 samples randomly. Then we just picked a sentence transformer so that we can able to directly encode the whole sentence. So by using that, we just picked the summary in the data frame and we encoded it, and we pick a question, and so in order to, and we also encoded that question, and we are using this util dot cosine similarity to identify the similarity between the question and the passage, or you can say paragraph or data frame embeddings, so that in our data frame whatever the related paragraphs we have, those all we get. And from that, we just want a top three. So in order to pick a top k, we are using a torch. We are picking a top k indices and we are printing the data frames. So at the end, it may take a few seconds. So just wait. We got some mistake, that is, I think no attribute items. Yeah, here we need to provide item instead of items. Yeah, let's rerun it to see the response. Now you can able to see it was generating. You observe one more mistake came, that is, yeah, here we use data frame embeddings, but here we specified only data frame. We need to provide that as well correctly. So let's interrupt it and let's retry it. Yeah, here we provided the embeddings. Yeah. So inside that embeddings, we are searching for the summary and we are printing the output. Why I'm getting error? Actually, yeah, this is the data frame. This is the list. So we need to connect it with the actual data frame, not with the list. Previously we were correct. So now let's rerun it again to get expected output. Now you can see it is generating me the result. So forgot about the warnings. Yeah, you can see. So top first one, second one, and third one also generated. So like this, three were generated, and so this is also relevant documents that is suggested by that model. And if you want, you can even ask with some another query like technology, like that. You can able to ask like politics. You can able to ask so nation and politics. Let's say I want to ask like this, and I want to rerun this to see this result related to the suggested documents on that particular query. Actually, it's progressing. Yeah, now you can see, yeah. So one, two, three results got generated. So elections related, yeah, based on the question that we provided, based on that only it was generated me the result related to documents. So in this way, actually, you can able to implement the similarity search. It is very simple. Let's recap it finally. We just imported this similarity, or we just imported this sentence transformer, and by using this model, we just encoded the data frames of our we just encoded the data frames of our document, as well as you can see this is the document related embeddings encodings, and this is the query related encodings, and we just implemented the similarity search by using the util. We just imported that util also from the same sentence transformers, and we fetched the top k similarities, and we just printed that top k similarities related summary inside our document data frames. This is how we can able to implement this semantic search or similarity search or the search of top three articles. So in this example, we just done searching of top three articles based on the query that we provided inside a documentation, right? Inside a data frame. So that's it about this video. I hope this video is useful to you. If you want to support me to make such more content, then such more informative content, then please like. Please provide your comments in the comment section below. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. See you back in the next video with another interesting topic. Until then, bye bye, guys.